Welcome once again to 10 Minutes with Harry. Today is a very important talk as I'll be showing an electrocardiograph which is often misinterpreted and therefore may lead to unfortunate circumstances with the patient in regard to therapy. The title of my talk is this ventricular tachycardia? Let me show you the electrocardiogram. You can see that there is a very rapid rhythm and that it is irregular, and quite clearly with the red highlight, this is atrial fibrillation with a very rapid ventricular response. But in the middle of the tracing, we can see a wide QRS. It has been diagnosed as ventricular run or ventricular tachycardia. It too is slightly irregular, as can be seen with the blue highlight. But is this in fact ventricular tachycardia? It isn't, and it is ventricular aberration, atrial fibrillation with ventricular aberration. In order to understand how aberration, well, I have to return to the footprints of an atrial ectopic, which can be seen here. Sinus rhythm, a premature beat with a premature P wave. The QRS is identical to the sinus-generated QRSs, and there's a compensatory pause. An atrial ectopic. Now, sometimes an atrial ectopic is conducted with ventricular aberration. And what do I mean by that? Well, depending on the prematurity, an atrial ectopic may be conducted to the ventricle during the relative refractory period, and I'll explain that in detail later. The ectopic QRS has a bundle branch block configuration, and this is often called a ventricular ectopic. Why does it occur? Well, aberrant conduction results from the intermittent, uneven physiologic refractoriness in the ventricular conducting system from an early supraventricular beat. There is QRS widening consequent to a delay or block in one of the bundle branches or a more peripheral branch. This sounds complicated, so let's try and see it using the action potential. As you can see here, there are two action potentials. Above is the left bundle branch and below is the right bundle branch. They are different in that the action potential duration of the right bundle branch, as can be seen, is usually, but not always, longer. This results in different absolute refractory periods in each of the bundle branches. In this example here, you can see that the absolute refractory period is longer in the right bundle branch. During phase 3, is the relative refractory period where conduction may occur. Now, as can be seen, that a premature beat may be conducted during the relative refractory period of the left bundle branch, resulting in aberrancy. That means that there is a zone of aberrancy here, which you can see where there'll be conduction through the left bundle branch, but not through the right bundle branch, which is in the absolute refractory period. There is therefore QRS widening, with right bundle branch block configuration. Let's have a look then at an atrial ectopic with aberrancy. We usually need V1 in order to determine right bundle branch block. We can see a P wave. There is a wide QRS, which has the appearance of an RSR and is called rabbit's ears. Have a look at an example of an atrial triplet with varying aberration. And this gives you the spectrum of aberrancy. At the beginning, we can see an atrial ectopic with no aberration. Then we can see a couplet, which shows aberration with rabbit's ears, and then there is a pause before the third atrial ectopic, and there is no aberrancy here because now it is outside that zone of aberrancy. Have a look at this ECG. Is it a ventricular ectopic or is it atrial ectopic with aberration? It most certainly looks like a ventricular ectopic, and most people would call it such. But there is no V1 in this example, so we can't be sure about a right bundle branch block. There is no P wave. The initial deflections, though, the initial R waves, are very similar, if not identical, to the sinus-generated QRS complexes, and this gives you a clue that this may be an atrial ectopic with aberration. So we need to look for later ectopics. So we now go to this Holter monitor and look for other ectopic activity. This is a very short distance between the QRS of the sinus-generated beat and the QRS of the ectopic. If it occurs a fraction later, one can see already the R waves are developing similar to the sinus-generated QRS complexes. A slightly later ectopic, and we can see that now the QRS is identical to the sinus-generated QRS, and we can actually see a P wave. Later still, and this is very obviously an atrial ectopic. So we can't always tell on looking at one QRS complex whether this is aberration or not, but we have learnt now to look at other complexes to see, as they often do occur later, and will declare what they are. Aberration with atrial fibrillation was first described by Guach and Ashman in 1947. Their concern at that time was whether the patient was having ventricular tachycardia or atrial fibrillation with aberration. The problem was generated by the use of digoxin, or digitalis leaf at that time, coming from the foxglove, a brown tablet with just the crushed leaf, but had no idea of how much digitalis was actually present in the tablet. Digitalis toxicity was extremely common. And as a result of this, if there was digitalis toxicity, atrial fibrillation with a wide QRS could actually be ventricular tachycardia, and that was usually the case. Whereas if they didn't have enough digitalis on board, then they would have aberration. So it was critical in those days to try and determine whether this was ventricular tachycardia or aberration. The phenomenon was called Ashman phenomenon. It occurred with atrial fibrillation. There was a right bundle branch block morphology. And what was important, what they described was the long cycle, short cycle, because the relative refractory period depends on the cycle length of the preceding cycle. Here is an ECG to demonstrate that. One can see the long cycle and then the short cycle, and this sets up the complex to fall within the relative refractory period, or the zone of aberrancy, and we now see a complex which initially looks like a ventricular ectopic, but it has an RSR pattern with rabbit's ears. And of interest, one can look below to V6, and often in V6, the QRS is more narrow, and there is an S wave, which is wider, which is part of the bundle branch block, but nevertheless, there is a clue that this possibly is a aberration. The Ashburn phenomenon can also result in left bundle branch block, even in the same patient. It can occur in series, such as with ectopics, couplets and triplets, or with in-runs with atrial fibrillation or other atrial tachyarrhythmias. It may not have a compensatory pause because of atrial fibrillation with a rapid ventricular response. The QRS of Ashburn phenomenon can be narrower than a ventricular ectopic in the, say, V6. So it's important to look at all these. Here is an example with a aberration with a supraventricular tachycardia. One can see that it is V1, but it looks like a ventricular tachycardia and is of concern to the viewer. But remember, this is an RSR phenomenon. And remember, prior to the aberration, there is a rapid conduction of the supraventricular tachycardia, and as it gets slightly faster, it goes into aberrancy. Here is a series of QRSs which can frighten the observer. You can see that it is V1. It's a right bundle branch block configuration with an RSR, and we can see that it's been called a ventricular run or ventricular tachycardia. But you can see the P waves in this example, and what is particularly important, as it gets slower, we lose the aberrancy. And therefore, this clearly is not a ventricular tachyarrhythmia. It is rather, it is an atrial tachycardia with aberrancy. We don't always have a V1, and therefore we are concerned with a tracing like this, that this may be a ventricular tachycardia. But we don't know if it's left or right block or bundle branch block because this Holter monitor has not got a V1. In this example here, we do have a V1, and you can see a very nasty looking tracing, and it's called ventricular tachycardia. But there is a long, short periods. We have got a rapid wide QRS, but this time a left bundle branch block, and another one exactly the same. So this clearly is an aberration, even though we do not have a right bundle branch block. But when we see this situation, look at other parts of the tracings, because we often see a right bundle branch block as well. Here is what happened when I looked further, and you can see V1 again. We have now got a long, short, and then we have a left bundle branch block. But if we look earlier, we can see that again, the long, short, and then a right bundle branch block. So here, within the same tracing, we have both left and right bundle branch block aberration. How do we differentiate aberrant conduction from ventricular ectopics or tachyarrhythmias? Look for the P wave, of course, with the ectopic. Look at V1. Generally, it's a right bundle branch block with an RSR dash configuration. With atrial fibrillation, look for the long cycles, short cycles, and maybe look at V6 to see if it's a narrower QRS. So what have I learned? Aberration may occur with atrial ectopy and atrial tachyarrhythmias. It's usually a right bundle branch block configuration. And it's very important to recognize aberration in order to not misdiagnose ventricular tachycardia. Thank you.